This here is the TOC machine, so it's comprised of the TOCV, which is the analyzer. This is the auto sampler, which is connected to the computer. So the TOC stands for total organic carbon. So in this machine you can look at total carbon in a sample, or you can look at total nitrogen in a sample, or you can also look at IC. So the way it works is TOC subtracts total carbon minus inorganic carbon, and that gives you the total organic carbon in a sample. But you can also analyze total nitrogen at the same time as total carbon. It's heavily used by the water industry, so for example, if you want to analyze water from a stream or even like treated water. So during the last MEC season we had 4 students using it at the same time. So they're using both machines. So for example, this one is for high concentrations and this one is for like clean water. You put your sample in one of these vials here, you open the auto sampler, you choose your position, you close the lid, so you select the method you want. The most used method is TOC, which is, as I mentioned, is TC minus IC. So you choose that one, you choose how many samples you'd like, and then you just press start, so the carousel will start to spin, and then there is a needle inside which will inject a few milliliters of the sample, and then there is an infrared detector at the back, and then it will give you the result for that sample. So if you have more samples, then it will do the same all over again. So it depends on the method, but it takes like 10 minutes per sample maybe. There is a few lectures that sometimes request us to analyze their samples, so sometimes they have postdoc students also working with them, so sometimes we are asked to help them with that. So the idea is like if the person is trying not to use the machine, they can do it on their own. If they are not trained, they ask us, and then we run the samples for them. Also, in the past, we've run samples for a few external companies, so we do some contract work, so they send us like 100 samples, 50 samples, and then we just analyze them and we send the results back to them. So this is like an indirect method of evaluating water quality. So if you find lots of carbon, it might be an indication that, so if it's drinking water, it's not good. It's the sample results table. So in here we can see the method we chose, and in here we got the results for TOC. So we got 50 milligrams per liter for TC and 25 milligrams per liter for IC. So that gives a total of 25 milligrams per liter of TOC. So this experiment was performed for an external company. So I think they're looking at organic carbon in some spinach samples. So myself and another colleague ran these samples a few months ago, and this was the result we obtained.
This is an elemental analyzer. It's similar to some respects to the TOC machines you've seen previously. The TOC machines, their primary use is actually measuring things like carbon and nitrogen in water samples. This is a similar type of instrument, but actually is measuring carbon and nitrogen and hydrogen actually in solid material. Now this solid material can be soil, it can be plant material, we've run plastic on it, we've run insects in the past, we've run some oily samples as well. It's designed to measure actually carbon, nitrogen and hydrogen. Samples typically that's an oven-dried and ground soil sample, which we actually measure into very small little tin foil boats. And you're only looking at measuring maybe up to 50 milligrams. So it's only a sort of a tiny bit of sample on the end of a spatula. There's actually quite a lot of time is spent actually making sure your sample is homogeneous. Because you're taking only a very small sample, you've got to be very sure that that very small sample you take is actually representative of the whole. So the samples are actually weighed into tiny little boats. They're folded up using tweezers and a steady hand to excluding air. Because you're measuring nitrogen, it's important actually you try to get as much air of the sample out of the sample as possible, because nitrogen is one of the things you're going to measure. So the samples are put into these little boats and are then actually loaded onto the instrument and analysed. In one of the large projects that we've done as a university was actually looking at levels of carbon in soil. We did, part of the university in the past actually took huge numbers of topsoil samples covering England and Wales, something like 5,700 samples. These were all analysed for a whole host of parameters. One of the parameters that was done was actually organic carbon. They were subsequently resampled about 15 years afterwards. And actually what it was actually looking at was actually were there carbon losses potentially linked in with climate change. It's also used within the energy group where they were looking at actually energy production from material. So a project that's been run on this machine actually was looking at incineration of waste. And what they were interested in actually then was the hydrogen content of samples, because that's part of the fuel. And it's actually used fairly substantially. So we've got a number of samples here that are waiting to be analysed. It tends to be something on the taught modules we will tend to, this is an elemental analyzer, this is what it does. When it comes down to projects, we will get the students actually, it's their responsibility for sitting there weighing all the samples into little boats. So we teach them through the system. We tend to run the instrument ourselves. Again, it depends on if someone's going to be using it on large numbers of occasions. It's then with somebody who will then train people in how the instrument works, and they'll be responsible for running the instrument. We try to get the students to be as hands-on as possible. In terms of the types of projects we've run, it's a variety. Lots of the projects tend to be involved with, particularly sort of the agriculture things, it might be ways of trying to increase the organic matter content in soil. Adding carbon, organic material to soil, dramatically, in most cases, dramatically improves the productivity of the soil. Samples are actually packed into tiny little aluminium or tin foil little boats, which are then very carefully folded to make a sort of a tight, sample-tight little parcel. And those are then actually fed into the machine, one at a time. They take 8-9 minutes per sample to run, but you actually always get, you get the carbon concentration, you get the nitrogen, you get the hydrogen concentration. Again, it's a machine, we can load it overnight, so we can run it overnight. Typically when we start running it, we'll run a batch of maybe 60, 70 samples in one go. The way the instrument works, it drops this little parcel of soil into the top of a combustion tube. That's running at about 1,000 degrees centigrade. It's actually held in a high helium atmosphere. So when that sample actually hits the tube, nothing really happens because it's in helium. There's no oxygen to cause any sort of combustion. It then squirts a small amount of oxygen into that same space until that sample is combusted. And it produces a mixture of gases. And the mixture of gases it produces are nitrogen, or nitrous dioxide, carbon dioxide and water. So those mixture of gases pass through the instrument and they actually get separated out into the 3 types. So the instrument actually works by separation of gases, and it will then measure them individually to give the individual concentrations. So actually the point of the tubes here is actually to remove any potential contamination. So these basically just absorption tubes to make sure everything is as clean as possible. Elemental analyzers are used across all sorts of different industries. So lots of industries would use them if they're looking at the content of those elements within any type of sample.